We begin by adding the desired analog output module to the I/O configuration of our Studio 5000 Logix Designer project. As with any other local module, we provide a unique name, indicate the physical slot location, and, if desired, enter a description of the module. When choosing a communication format, we decide whether or not this controller will own the module. If not, we choose one of the listen-only options. In this example, this controller will own the module, so we will disregard the listen-only options. If we want to write decimal values to the output channels, we choose one of the float options. If we instead want integer data, whether scaled to include fractional values or not, then we choose one of the integer options. For this example, we will use float data. Now we configure the expected firmware revision as well as the desired electronic keying behavior. Since we will configure our channels at this time, we go ahead and check the Open Module Properties box and click the OK button. Moving to the Connection tab, we can adjust the requested packet interval as necessary for the application. In this example, we maintain the default value. In the Configuration tab, we begin configuring the individual channels by selecting our first channel. Now we can configure the scaling. For this example, we assume that this channel is connected to a control head on a ball valve. The valve expects a signal from 0 to 10 volts that represents an opening of the valve from 0 to 100%, so we configure the scaling accordingly. Now we would continue configuring all channels in use. Next, we move to the Output State tab. Again, we need to select the channel that we wish to configure. Then we can specify the state of the channel when the controller is switched to the program mode. We can have the channel hold the last state or go to a user-specified value. We may also choose to impose ramp limitations upon the output signal as it moves to the user-specified value. We may similarly specify behavior in the case of a fault. Finally, we choose which of the above configurations applies to the channel in the case of lost communications when the controller is in the program mode. Moving to the Limits tab, we may now limit the signal range produced by the channel. For example, even though we have a scaling range of 0 to 100%, we can impose limits from 20 to 80, and the signal will never wander outside of these limits, regardless of the value commanded in logic. To limit the rate of change to our signal, we check the ramp and run mode box and provide a value in engineering units per second. In addition to constraining our signal, the module can provide alarms for instances when the commanded signal exceeds specification. Of course, these may be disabled or latched as desired. Clicking the Apply button and the OK button, our configuration is saved and we are ready to download and test operation. Let's configure a quick watch window to take a look at and control pertinent data for channel 0. So we can add the signal data itself, the rate alarm, as well as the low and high clamp alarms. For this demonstration, we have a meter wired to the channel so we can take a look at the actual signal that would be sent to our ball valve. Here we can see that because our initial value is 0, the signal is clamped at the lower limit of 20. Furthermore, the low alarm is currently active. Entering a value of 20, we see that because we are at the lower limit, nothing changes. If, however, we enter a value of 40, we see the rate alarm go to high in response to our step command, and the signal is ramped to 40% at a rate of 10% per second as specified. Now none of our alarms are active. And as long as we stay within the clamping boundaries, our low and high alarms do not turn on. While exceeding the upper boundary activates the high alarm. Switching to the program mode, we see the channel respond by ramping to our user-specified value of 50%. And that's it. Our analog channel is ready for use. As a last step, let's apply a name to our Quick Watch window so that we can pull it back up when our valve is wired and ready for testing.